We are continuing to explore congruent triangles and the theorems that we can use to prove that two triangles are congruent. So we have three additional ones today. We have angle, side angle, 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 side, and hypotenuse leg. The first one, if two angles and the included side of one triangle are congruent to the corresponding parts of another triangle, then the two triangles are congruent. So this one's talking about two angles and the included side. So that would have to be the side between those two angles. So looking at these two triangles over here, that would maybe be this angle congruent to that angle. And this angle, that's supposed to be 2, is congruent to this angle. And then the included side would be the one that connects those two angles. It is a side of both of those angles. So if the two angles and the included side are congruent, then the two triangles are congruent. We would call this one angle side angle, ASA. If two angles and the non-included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are also congruent. So like for example, once again, if I said this angle and this angle are congruent, and this angle and this angle are congruent, and then we said a side that is not the included side, so this one to that one. So these two are not between those two angles. This side is not a side of both of those angles. But these two triangles are still congruent. This is just by another theorem. This one is angle, angle, side. And then the third one has to do with right triangles only. This one is called hypotenuse leg. We abbreviate it HL. And this one says that if the hypotenuse and a leg of one right triangle are congruent to the corresponding parts of another right triangle, then the right triangles are congruent. Okay, so hypotenuse leg, the hypotenuse is the side that is across the triangle from the right angle. So on these two, if the hypotenuse of this one is congruent, to the hypotenuse of that one, and then the leg would be one of the other sides of the triangle. So maybe the short side here, we'll say the short side on this one is congruent to the short side on this one. This would make these two triangles congruent, just knowing the hypotenuse and the leg of the two triangles are congruent to one another. Alrighty, so we're going to be looking at some examples of these. I'm going to get a prettier color to work with now. So our first one here, this one is the angle side angle postulate. There is a picture here, very much like the one that we had up at the top where we drew in the angles. This one says that angle A is congruent to angle X, and angle B is congruent to angle Y, and the included side, AB, is congruent to XY. So we've got all of that information here. Angle A congruent to angle X, angle B congruent to angle Y, and side AB congruent to side XY. Since this is two angles and the included side on the two triangles, we can state that these two triangles are congruent. And we would write a valid congruent statement where the order of the angles matches up from one triangle to the other. So triangle ABC is congruent to triangle XYZ. ABC congruent to XYZ. Second one, angle side angle. Angle side, AAS. So we have two pictures, two triangles here, and they show us with the arcs that angle A is congruent to angle Y this time. And they say angle B is congruent to angle Z with two arcs. And they also tell us that side AC is congruent to side YZ. Oops, that's a typo. AC is congruent to YX. That's supposed to be an X. All right, so because we have two angles and the non-included side congruent from one triangle to the other, then we can say that these two triangles are congruent. So we would have triangle ABC, so ABC, congruent to XZY, so XZY. And that would be a valid congruent statement because it goes in the same order. Actually, oh, I read it wrong. Let me try that again. All right, here we go. Okay, so the second triangle is YZX, this way. There we go. Okay, so they do go in the same order, touching all of the congruent parts in the same order from one triangle to the other. The third one, we've got another example here of hypotenuse leg. Now, this isn't something that was stated specifically in the theorem, but the measure of angle A and the measure of angle X are both 90 degrees. They're equal to each other, and they're 90 degrees. That is what makes it a right triangle. So the hypotenuse on each of these is BC from this one, and that's congruent to YZ on this one. Those are the hypotenuse of the two triangles. They are across from the right angle. That's important. The leg, AB, they tell us is congruent to the leg. XY. My eyes jumped. Okay, XY on this one. So therefore, since we have right triangles and we know the hypotenuse is congruent on the two triangles and one of the legs is congruent on two of the triangles, we can say the two triangles are congruent. And so we write a valid congruent statement. Again, ABC for our first one. So we're starting at the right angle and we're going to the side with one tick mark. So X, then Y, then Z. Same order on the two triangles. All right, so there's a little guided practice on these. For each of these, you're to determine whether you can use angle, side, angle, angle, side, or hypotenuse leg to prove that the triangles below are congruent. If you can, then you'll finish the congruent statement that's here. But if you can't, then you write not possible instead. So this would be a good place to pause the video and see if you can figure out whether or not these triangles that are given are congruent, and if they are, write the congruent statement. Okay, welcome back. So the first two triangles are congruent by angle, side, angle. Since they have a shared side, we know that that side is congruent to itself by the reflexive property. So when we name the triangle, ABD goes this way, so its congruent triangle would be CBD. The second pair is congruent by angle, angle, side. They tell us one angle and they tell us one side, but then we've got these two angles are vertical angles, so we know that they are congruent as well. So CDB is congruent to, we'd have to start at AEB. This next one, we do have right triangles. There was some information missing from my picture. I fixed it on yours, but I had to fix it on mine. So let's see. So this is, we have the hypotenuse and we have a leg on each of these two right triangles. So it is by hypotenuse leg, HL. And for the first triangle, they named it GHF. So its congruent triangle, we would have to go across the unlabeled side, JKL, in order to name the triangles. For the next one, it is angle, angle, side. They tell us two angles. They tell us this angle and then a right angle from each of the triangles. These two triangles share a side, so we know that this side is congruent by the reflexive property. So you might have accidentally called this one hypotenuse leg because you were like, oh, it's a right triangle. So that's a little bit tricky. You got to be careful there. So we've got FGE is how they named the first one. So they went across the hypotenuse, starting at the apex up here and going across the hypotenuse first. So when I do this one, I'd have to do the same. So HEG, hypotenuse first, and then the shared leg. And the last pair are congruent by angle, side angle. Again, they give us two angles in each of the triangles and tell us that there is a congruence relationship there. And then the two triangles do share a side. So we know that that side is congruent to itself by the reflexive property. So when they named the first one, they said BDA. So when we name the second one, we have to name it in the same order. So we start with the angle with two arcs on it, B, and then the angle with one arc, and then we go to the other angle, so BDC.